Hello, welcome to another filament dryer testing video, the fourth one in a row. These two boxes are sent to me by the Polymaker in exchange for the review. This is the Polydryer and this is the Polydryer Box. And with this unit we can dry the filament, but this is also a storage box too. This means we can remove the dryer part and attach to another box, and we can dry the filament before we start with the printing with it. Few specifications from the website. The maximal spool size is 205 mm in diameter and 78 mm wide. It uses 65 watt PTC heater. It has very simplified screen, so we can see there the power levels, and also we can see the countdown time. There is no temperature on the display. We have the humidity sensor display on the box itself, and it uses the separate battery. I'm not sure about the battery life, but I have similar solution on one of the iBoss filament dryers. This one is 2.5 years old and it still works. Now we can see some silica gel is included, and this is the color changing silica gel, so we can see when it requires drying. But actually the silica gel will help during the drying process, but also it will reduce the moisture during the storage. But if we start the drying, after some time, when the humidity reduces, it will start with the drying not only the spool but also the silica gel. So we can see again some color changes on it. This is a nice solution, so we don't have to dry it separately in the microwave or something like that. According to information on their website, the box changes 5% relative humidity in 30 days. I don't have so long time for the testing. Maybe there will be some short video about the testing only the box. Now let's see what's inside. I almost thought that I got two identical boxes, but probably the dryer is inside. And also I forgot to mention that I was involved in the development phase to DS for my devices, and I did it for free. I mean, I just want to improve products, and same for this video. This is not a sponsored video. I got these boxes for free, but I'm not paid anything above this, and I will just show you the facts and my measuring results. Outside of these boxes we have the Teflon tubes and the user manual, and it is equal in both cases. The Teflon tube is 0.5 meters long and the inner diameter is 3.7 millimeters. Let's open first the storage box. I pulled out the insulation so the battery will be in contact, and it starts with operating. It uses two LR44 batteries. The top cover has a nice sealing line here, it's made from the rubber. This is the color changing silica gel. And we can place the spools on the bottom rollers, or we can use this one. And it rotates more smoothly, but this is not what is important about this one. I have this very soft TPU filament. TPU is very sensitive to moisture, and I had always the problem to dry it because usually the distance between rollers is too big. And with this, finally I have a proper dryer for this filament too. These are airlocks. We have to remove them to connect with the filament dryer, but of course after the drying we have to place them back, and they will keep the sealing. We have to cut the bag and pour the silica gel into the desiccant box. It goes to the same side where we have the exit for the filament. We have two exits for the filament, one on the top and one to the side, and they are resealable. And we can also use this for the locking end of the filament. Using of the Teflon tube is highly recommended, otherwise it will be too big friction between the filament and this rubber. Now let's open the dryer. I already presented this part of the package. Additionally, we have the power adapter, and the output is 24 volts and 2.83 amperes. This is EU plug. And this is the dryer itself. So we have the inlet and outlet of the air, and here it will let the moisture out during the drying, and this is the display with some buttons. This is the sticker with guide which power level we should use with these materials, and this is the drying time. I'm preparing the second box using the same method like previously explained. Inserting the silica gel and removing the airlocks. Length of the power cable is 1.5 meters. There is a plug and a switch on the back side. Maybe these locks are a little bit too tight. I'm not sure if they will wear by time, but it could be a little bit softer. Let's check the screen. Oh, this beep is horrible. With M button we can change the power levels. Now it's level 2, level 3 or level 1. With this we can adjust the time and it jumps every half hours. And with this we can start or pause the drying. It's not super quiet. I will measure the noise later, but this beep is horrible. Now it is time for my regular sponge test where I'm adding 2 milliliters of water I'm placing inside the dryer, and I will measure the weight after half hours and after 1 hour. Not perfectly comparable with the drying of the filament because this is mostly the surface drying. With drying of the filament we have actually two stages. We need the higher temperatures to force that moisture to the surface of that filament, and then we need a dry environment, and that from that surface that moisture will evaporate. But at least this is some kind of experiment which I can repeat with other filament dryers, and actually I will have soon that 6 or 7 dryer comparison test, and there actually I will dry the filament. Okay, let's start with the test. During this experiment I want to record the power consumption too. I want to record the values after half hours and after 1 hour. And actually this is something I want to repeat with all other filament dryers too, because I have the feeling that this kind of system works better compared to those which acts like a food dehydrator, where the hot air is let out from the dryer. On winter it is okay because we heat the room, but on summer it is wasting of energy. There will be the position of the sponge, and since the air circulates inside, so probably we have different temperatures on two sides, I plugged another DHT22 humidity and temperature sensor. The data I am collecting with Arduino Uno and my laptop, but also the current temperatures and the humidity we can see on this display. This is the weight of the dry sponge. And now I am adding 2 milliliters of water, but I am measuring the weight, it is more accurate. Actually the mass, not the weight. Goes inside. And I'm starting the heating and measuring the time. The power is set to level 3, the strongest one. Here you can see the position of the sponge and also of two sensors. This is the noise from exactly half meter distance, approximately 40 decibels, a little bit more. Not the quietest filament dryer, but quieter than those which I tested in 2024. There is a comparison table on my website, so you can compare this data to other filament dryers. And also in that comparison video, I will also compare the noises side by side. After 16 minutes, the temperature inside are 48 and 52 degrees Celsius, very similar temperatures, and the humidity is approximately 35%. According to their sensor, the humidity is 50%. But of course, this is measuring properly the humidity of the circulating air, and this in these two positions where the sensors are. On this power consumption meter, I can see that it turns on off the heater. When it's heating, it uses approximately half amperes. And so far the consumption is below 0.01 kilowatt hours after 25 minutes. This is the measuring after 30 minutes of drying. Let's check if we can see something interesting through thermal camera. There are no significant peaks, but definitely we can see the heat source and the inlet of the hot air. After 15 minutes, the temperature inside 52 and 56 degrees Celsius, and relative humidity according to their sensor 20%, according to mine 18 and 19. Quite close. Not sure how important is this, but this display is very crisp and nice, but only from this angle. If I watch from the top angle, it's a little bit hard to see. Half more minutes, and according to their sensor, 19% humidity sensor, very similar to my values, and 56 degrees Celsius is the peak. And the power consumption 0.02 kilowatt hours, really minimal. Completely dry, 641. And I will collect some cooling data, 10 more minutes. It is time to collect the data, but I also have one important test. As you can see, I lowered this sensor as much as possible, and I will try to measure the temperature of the hot air. And I will clean the output, and I'm starting collecting the data again. After approximately 15 minutes, the temperature stabilized around 68 degrees Celsius, which is good. Don't forget I'm on power level 3, and it will not melt our filament or spool. I will turn off the dryer, and then I will see the hot air temperature on power level 1. Let's say we want to dry PLA. Power level 1. And I'm collecting the data next 15 minutes. Position of the sensor is same, and actually approximately 20 millimeters below the surface of the filament. And after 10 minutes I can see that the temperature stabilized around 50 degrees Celsius, which is good. This means our PLA filament will be safe inside. With the red you can see the temperature lines, and with the blue the relative humidity. This is 30-minute measuring, and this is 1 hour measuring when it was turned off, and this is some cooling. The maximum temperature was 56 degrees Celsius. About relative humidity. Usually I can see faster decreasing of this curve, but here the humidity was let out on the side. I'm not sure how good is this solution. Usually it is let out on the top. At the end the relative humidity was reduced too, so the method works, only a little bit slower. On the sponge drying test, after half hours it removed 92% of the water. After 1 hour it was completely dried, so it performed quite good. This is the temperature of the hot air when the dryer was set to level 3. And it was very close to 70 degrees Celsius. And this is hot air temperature set to level 1. Approximately at 50 degrees Celsius it is safe even for PLA. Now some conclusions for the end. I really like this modular system, and definitely I will use these boxes to store some of my important filaments. Of course I want to see how it performs compared to the vacuum bags, the current solution I'm using for these important filaments. Drying capabilities are good even if the maximum temperature was a little bit below 60 degrees Celsius on this position you saw where my sensor was placed. Of course the temperature of the hot air was nearly 70 degrees Celsius. Maybe if the spool is inside, the temperature of the air is more equal, but even then it will be good to open it from time to time and rotate a little bit the spool to have more equal drying. The real test will be actually in few weeks when I will compare again 6 or 7 filament dryers in one video, and actually there we will dry the filament, which will be nylon. Actually it will be PA6 CF by Polymaker. It has space for improvements. For example, I don't like that this locking mechanism is too hard. I'm not sure if it will wear by time, but it doesn't have to be so strong. I really cannot accept that beep sound, it's really annoying to me. This hygrometer or relative humidity meter, when it is between two values, it jumps up and down every half minutes, but what is confusing that it jumps by 4%, not by 1 or 2%. And a small idea for version 2. What if we could have a valve on the top of the box and we could suck the air to create some vacuum inside, similar to existing food storage boxes. Otherwise, I really had a positive experience with this dryer. If you had some additional experience, write me down in the comment section a few lines. Thank you for watching and happy drying and printing.